Hello, it's Chemistry A, Unit 2, Periodic Table, Day 3. It's Mr. Wonderful here one more time. Let's get started. We're going to talk about the periodic table and what it can tell us. And the periodic table is broken up into all 118 approximate elements, and in each element has its own box on that periodic table. And that box shows us 4 key pieces of information. Sometimes they show 5 key pieces, and yours does in the book. I'll explain that a little later on. So information in each box includes the element name and the symbol. So we have the element name, the symbol. We have its average atomic mass or weight. Sometimes you'll see it as atomic weight. We call it atomic mass. And it has the atomic number, which is, of course, is the number of protons. And some, like I said, will include another piece of information, electrons in each energy level. If you look at yours in the book at this point, you will see these little numbers, and I'll explain those when we get to that in class. Now, electrons play a key role in determining the properties of an element. Also, elements can be sorted into noble gases, representative elements, transition or intertransition metals based on their electron configurations. Let's first of all take a look at the noble gases. This main group is the group 8A or group 18 on your periodic table. The A elements are signified by the A. Some periodic tables have both group 8A or 18. Some will just have the columns numbered 1 through 18. So that's why I'm telling you both. Now, we also say that the noble gases are called inert because they really rarely take place in any kind of chemical reaction. They don't react very well at all. That's one of the reasons why we use noble gases in neon lights. Neon is a noble gas. It is not very reactive, so we use gases like neon in a lot of our lighting. Now, noble gases are also characteristic of the noble gases are that their highest occupied energy level is full of electrons. They cannot take any more electrons, and that's why they're not reactive. If you look at this chart right here, we have helium 1s2, neon 1s2, 2s2, 2p6. That last shell, that 2s2 plus 2p6 equals 8. 8 is the magic number when it comes to whether an element will bond or not. If these last two elements, these last two numbers signify 8, that means it will not bond. Now, each little number there represents an electron. So if you take a look at neon's total electrons, they have 10 total electrons, and they're spread out in that atomic orbital. The S's, the P's, and the D's, and the F's. And we'll get more onto that when we talk about that in our bonding, but just keep in mind that that means that in the S orbital there are 2 electrons, and the 2s orbital there are 2 electrons, and in the p orbital in the 2 there are 6 electrons. And then argon, as you can see, 1s2, 2s2, 2p6, 3s2, 3p6. Now the main number there, the number 1 here, 2 there, and the 3 are the primary principal energy levels. And remember, within each energy level there are sub-energy levels like we talked about in day 1 notes. Okay? Notice, except for helium, the last 2 numbers equal 8. Every element in the noble gases, except for helium, will equal 8. We'll have 8 in its outer shell. That means it's full. Okay? The second main group that we can break these down to are the representative elements. Those are group 1A through 7A, or columns 1 and 2, and 13 through 17, depending on which way your periodic table, or the one you're looking at, is listing it as. The representative elements display a wide range of physical and chemical characteristics. Some of these representative elements are metals, some of them are nonmetals, and some of them are metalloids. The representative elements, their highest energy level is not filled. So unlike noble gases where they have a total of 8, representative elements will only have 1, 2, 3, all the way up to 7, and they are not full, therefore they will react. Now, for any representative element, its group number equals the number of electrons in the highest energy level. For example, 4A. We'll take a look at that in just a second, but I want to make sure you understand this. Group 1A, only the A elements, all the electrons, all the elements in group 1A will have one outer shell electron. Group 2A will have 2 outer shell electrons. Group 3A will have 3. Group 4A will have 4, all the way up to group 7A, which will have 7. Now group 8A has 8 already, so I guess you can include that, but it's not a representative element. So let's take a look at carbon. Carbon, 1s2, 2s2, 2p2. You add those two up, and that equals 4, a group 4A element. Silicon, last 2, 3s2, 3p2. It has 4 electrons in its outer shell. And germanium, look at all these electrons. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, but look at the outer shell. 4s2, 4p2. The next element down would have all of this plus at level 5, but the last 2 would be, you guessed it, 5s2, 5p2. And then the third group is the transition elements. Those are the B elements that we see on our periodic table, or elements columns 3 through 12. They can actually be broken up into 2 different types of transition elements. Okay, they are classified by their electron configurations. The A, the transition metals, are the highest occupied S sublevel in a nearby D sublevel. They contain electrons, and they are characterized by presence of electrons in the D orbital. So if I asked you, student, I have an electron I have an element that has electrons and that has d orbits fold, or it has presence of d orbits, you're going to tell me it's a transition metal. Okay? And if you look at the picture down here, if you look at the picture, we have the S block. Now here's the D block. So these are all the B elements. Okay? All right? Now the inner transition metals appear below the body. Remember that group that I said that was pulled out from somewhere over in here and put down below? They have F sublevels containing electrons. So right in here. And they are their highest occupied S sublevel, and a nearby F sublevel contains electrons. When we talk more about the how things bond, we'll get into this a little bit more specifically. But as you can see here, just like on your note guide, you have the S, the P's, and the D's, and the F's.